In this video we're going to look at a pretty simple example that incorporates everything we've learned about vertical curves. And in this example we have a vertical curve already drawn out, and we have the entering tangent and the exiting tangent. And there's a couple things several things we want to find. First of all, we want to find out what the elevations of BVC and EVC are. So BVC is the beginning of vertical curve, and EVC is the end of vertical curve. And we also want to find out the elevation of this point right here, located right at the PVI. The third thing we want to find out is where the highest point on this curve is located, and the last thing we want to find out is what the elevation of that highest point is. So we need to find the elevations of BVC, EVC, this point right here at the PVI, and then also the elevation of the highest point on this curve. And if you remember, most vertical curves, the highest point doesn't occur at the middle of the curve. In other words, the highest point is not always at the PVI. In this case, this is a crest curve, so we have a high point. If we had a sag curve, we'd have a low point. So the first question was to find the elevation of BVC, beginning of vertical curvature. And that's located at station 20 here. And then the end of vertical curvature is located at station 30. That means the length of this vertical curve is 10 stations long. So the first thing we want to find out is the elevation of BVC and EVC. And we can do that pretty simply. We know the elevation of PVI and we know the grade. And we also know that PVI is located at 25 plus 0, 0. It's at the middle of this vertical curve. So we can use the 608 elevation of PVI. We can use the distance of 20 and 25, so that's 5 stations, and we also have the grade. Entering grade is 2%, so simply 608 minus the grade times the distance in stations, so this is in percent. Well, you would keep it as the number as it is in percent times the station. So it's 608 minus 10, and that gives us an elevation of 598. So the elevation of BVC would be 598.00. Alright, our second question was, what is the elevation of EVC, or the end of vertical curvature? And we apply the same concept here, same grading concept here, right? 608 minus, because you're going down, a 1% grade. So you have 1% grade, and you also have a distance of 5 stations here. So 608 minus 5 is equal to 603. So the elevation of EVC would be 603.00. Alright, so we basically applied what we knew about grading to this problem, and we figured out what BVC and EVC are. And if you don't exactly know what I did here, I suggest watching the videos on grading. Our second question, which is going to pertain to the vertical curve itself, is to figure out the elevation of this point. So let's say Simi was standing at that point right there. See, that's me. We want to figure out what the elevation of that point is along this vertical curve. And we discussed in the last several videos, we have an equation for that. The equation is EP is equal to E BVC plus the entering tangent grade times the distance x plus ax squared. Right, so EP is the elevation of any point along this curve. EBC is the elevation of the beginning of vertical curvature, and we just figured that out. That was 598, right? Plus grade 1 times x plus the term ax squared. So we know that our location for this curve, this point, is located 5 stations from BVC. Okay, so that means x is 5 stations. X is simply the distance from BVC to the point you're interested in. The point we're interested in is the one I'm standing on, right? And that's located 5 stations from BVC. So I'm actually going to solve for the A term first, just so we can get that out of the way. The A term, I'll do it in blue, remember from the last several videos, was G2 minus G1 over 2L. And remember, if X is in stations, which it is, we want the grade to be in whatever percent form it is in currently. We don't want to convert the percent into decimal. So A is simply grade 2 minus grade 1, and grade 2 is -1 minus grade 1 is 2% over 2 times L. Well, the length here is 10 stations. The length of the curve is 10 stations. So we're left with -3 over 20. That's our A term. So we simply plug that A term into our equation. We have X, we have G, and we have the elevation of the beginning of vertical curvature. So let me do that in red, I suppose. The elevation of that point that we're interested in is EBVC, which was 598, right? Plus grade 1, which was 2%, times the distance 5, plus our A term, which is -3 over 20, times 5 squared, x squared, right? If we do the algebra here, we'll have 598 plus 10 minus 3.75, and 3.75 is this term, right? -3.75. And if we do the math, EP is going to be at an elevation of 604.25 feet, right? So EP, which is this point right here, is 604.25. Alright, so there's also another way to do this. If your X was in feet, your grade would be in decimal, right? So 598, and this is, I'm just showing you that you have to stay consistent with the distance and with the grade. So in this term, or in this equation, we made sure our grade was in the percent form it's in, and then X is the distance, and we kept it in stations. Let's say, let me erase this or cross it out. Let's say we wanted X in feet and we wanted the grade in decimal, right? So let's plug it in as X is equal to feet, or X is in feet, and the grade is in decimal form. We still have the 598. That doesn't change. That's your elevation. Plus 0.02, right? 2% divided by 100 gives you 0.02. That's its decimal form. And then remember, from stations to feet, you would simply multiply X by 100. So our X was 5 stations, or 500 feet, plus our A term, and let me do A on the side here really quick. A would be -0.01 minus 0.02 over 2 times the length. The length is in feet, so 10 times 100 is 1,000. And if we multiply, or I'm sorry, if we do this, we're going to get A is equal to -0.0000015. Okay, so if you plug that in, -0.0000015 times x squared, or 500 squared, we should get the same thing, 604.25 feet. Alright, so in the next video we're going to look at the highest, or finding the location of the highest point, and then using that information to find the elevation of the highest point.